Hello everyone, welcome to exam prep section number 1 for Data 100. So usually the distribution of exam prep resource will follow the following format where we release a worksheet, a solution, and then we will also have a recording that talks about the worksheet. Now, given that the exam prep worksheet is not going to be that different from what you have last semester, if you want a live recording of the worksheet solution, you could also look at the section recording from Spring 2024's offering, but because the worksheet content will be still slightly edited to follow the scope of each week's lecture, there will also be solution walkthroughs like this where we just talk about the solution of the worksheet. Okay, so with that being said, let's probably look at one of the questions in the exam prep worksheet and start working on it right away. All right, so this week's exam prep worksheet will mostly be about pandas. In the first question, or usually in exam questions, we'll give you a picture of the data frame that you're supposed to work with, just like the following. And we'll give you some information about the columns that the data frame is going to be about. So for example, this is a pandas data frame about panda that contains two columns, which is the age and the height of pandas. Well, the column height has a unit of centimeters. This is something we should note later because a question would talk about this. So let us first convert the pandas height into values with meters. Create a column height in meters that has each panda's height in meters instead and add it to the data frame panda. So in order to first create a column in the data frame, we can say something like panda and then bracket and then the column name, which is height in meters. And then we create this column, or we assign this column to the related column name by saying it's equal to some value. So this works really similarly to dictionary updates, which you have probably seen in your homework already. All right, so previously we said that the height of the panda is written in centimeters, and now we want it in meters. So it's actually just equivalent to the entire column for panda divided by 100. Therefore, we can write it as follows. Note that in pandas, when you do an arithmetic to an entire series, it's actually applied to every single element in the series. So this column will have this divided by 100 arithmetic applied to every single height you see in the column. Okay, so that's the first subpart, not that bad. Let's talk about the second subpart. We first want to know whether there is a relationship between a panda's age and height in meters. So write a one-line expression to calculate the average ratio between a panda's height in meters and age for all pandas in our data frame. So we want the average ratio. Therefore, the question can actually be seen as a two-step procedure where you first find the ratios, which once again we can divide two panda series columns to help us find the ratio, and then we can take the average of the ratio. So first we can say ratio is equal to, well, we're trying to find the ratio between the panda's height in meters and age, so we would say something like ratio is equal to panda height in meters. Or you could just redo the divide by 100 expression here, but I'm just going to use the column name that we have used before. And then we divide this by panda of age. And once you do that, you can take the average of the ratio. There are a couple of ways to do this. You can do something like np.mean of ratio. Here I'm just going to say ratio.mean because that's a valid operation to call. Okay, so that's the second part. Probably not that bad as well. All right, so now we can talk about part C. In part C, we're trying to get the median of the median height of each age. So here we're assuming that we can first group every entry in the data frame by age, and then we can get the median height. So, well, judging by the wording I said before, you probably already discovered a hint that this requires a group by operation. So namely, what we'll do is we'll first group every entry in the data frame using the age variable, and then we'll aggregate height by using the median function. So the concrete way you would do this in code is something like panda.groupBy. Here you have to put in the variable name you're trying to group something by. In that case, what we choose is age. And then you can say .ag. And then you can put an argument in here. Now there's a couple of ways you can achieve what you want. The easiest way or the most intuitive way of doing this is you can first index for height and then just dot median. So that's the easiest way to get the median of something. But you could also do something a little more fancier, although the return type will be a little bit different. So for example, you can say .ag and then put in the dictionary here, put the column name and the corresponding aggregating function. In this case is mp.median. And that will return you the same thing, except it will return you a data frame instead of a series. And then to get a series, you can always just index for height in the end. Okay, that's part C. Last but not least, expanding on the expression from the previous section, calculate the median ratio between a panda's height and age for each age. Write pandas code to accomplish this. So there are still a couple of ways to do this, but the easiest way would, there are still a couple of ways to do this. One of the way is that you can change the ag function here such that you directly index the height and the age column when you're trying to write your own aggregation function. And you can insert it in here, roughly this position, except maybe you will not use a dictionary as your input. Or the other easier way out is you first create a ratio column. Such that now you have a column dedicated to ratio. And this is something we have done in the previous parts. Okay, so once you have done this, you can then use the group by that we have done before. So it's for each age, which means we'll call group by based on age. And then, once again, index the column you want to aggregate over. And then you can just .ag median. Okay, so that's yet another way to call median inside your ag function. Okay, so that's the first question of the worksheet. Now, usually this worksheet would also involve a question in pandas merge and pandas pivot table, but since it's not taught this week, we'll just not bother about it. Let's also look at the second question, which is an Olympics thing, which just happened, I think. So now we have an Olympics dataset containing the name of all athletes, including several games and several events. First, let's try to write pandas code to return the 10 most common middle names among gold medal winners as a pandas series. So, it also tells us that the column name contains the first name, the middle name, and then the last name of each athlete that are separated by space. You can assume that all athletes at the table have a middle name. You can assume that everyone's name is unique. So what that grants us is first, we can find a way to get the middle name. To get the middle name is equivalent to getting the element B within this specific format where there's a word, space, word, space, word. So one of the easier way you can try to do this is you can use .str.split, which will return you the list ABC, and then you try to get always the B element, the middle element, by doing another indexing. The concrete code of this we'll write later. The other thing you want to notice is that we only want names among gold medalists, so we actually have to first filter every athlete such that there's a gold medalist. So here's the first thing you need to do, and the second thing you need to do is to get the middle names. And there's the last thing you need to do, which is to return the 10 most common middle names. Okay. And to return the 10 most common something, you can rely on the value count method, which will automatically sort something for you. Okay, so let's filter first. First, I need to filter such that I only have entries of gold medals left in my data set. And specifically, I also want the column name, so I'll just do that now. Okay, the expression is going to get long, so let's do a breakline here. Note that this is 1 dot str dot split. So now the middle output of this is a series of lists of string, and then we get only the element of index 1 by saying dot str bracket 1. Okay, another split here because the expression is getting too long. And note that was for objective 2. Now we have the last objective, which is to call value counts so that you can sort the namespace on your occurrences. And then you can get the index of this series, which will talk about the names, and you take until the 10th entry. And that's the solution for this subpart. Now let's look at subpart B. Which of the following lines of pandas code will output the most number of medals won by a single athlete? Well, we can first judge options A and B, and we can see that the group by object only targets the column ID. So in this case, we'll only get information about the the counts of entries that exist within each ID. And that's not giving us the amount of medals won by a single athlete. So A and B are actually not correct options because they simply do not help with our question's objective. In part C, instead, we select columns like name and medal. We group by the name, and then we sort the resulting group by .count return, which gives us the amount of medal that we see for each name. And then we sort it based on the count of medal that we retrieve for each name, and then we choose the name that's on the top of the list, which should have the largest amount of medal. So that looks like a reasonable option. Part D says something very similar. The problem is that it uses .size, which includes non-variables, which includes name values. But NaN values in our dataset is supposed to represent the fact that there's no medal. Therefore, option D cannot be chosen. For subpart C, we're instead trying to get the oldest athletes to participate in each sport along with the corresponding year. So, this doesn't really detail the format of the return data frame, but in this data frame, we're supposed to return the column year and the column name for each of the related criteria. So first, we can try to sort the data frame by age. And by sorting the data frame with the age, we can make later operations a little bit more convenient to us. So let's first sort by age. Remember to put ascending is equal to false. And then what we want to do is we want to target each sport and look into it. So we have to group by for sort. So once we group by sort, we can then look at the name of the first name that appears for each column, because as we have sorted the values before, now the top name is going to be the oldest. So now let's aggregate. And remember that we wanted two columns, the year column and the name column. And the function that we can use for aggregation, since we're trying to get the first entry, is just first. So year column first and name column first. Okay, now the last subpart of the worksheet. Fill the blank below to return the name of all sports for which the athlete's average age is over 25 years old. For here, what you want to do is you will still want to group by, but instead of using aggregation, you want to filter out the groups that do not have an average age of over 25 years ago. So this warrants the use of a new trick called groupBy.filter, which is another group by multiplication that you have taught about in the lecture. So we will first group by sport, just like we always had. And this time we'll call filter. And for here, you will input a filter function that targets, you can imagine, kind of the data frame representation of a group. And you want this function to return true for all group that you're trying to keep. For example, we're trying to keep the groups where the average age is larger than 25. So we'll do this. And now it will keep every group that fits this criterion for us. Now, last but not least, we can index the outcome by sport. So now we have a column that describes all of the sports that are left over, but there is still some repetition because we just kept every data entry from the group. So at last we call unique to extract every single sport's unique name. Okay, so that ends the solution for this worksheet. The next worksheet will be slightly longer and we'll be expected to talk about regular expression and some more pandas topics.